Award-winning futurist researcher and keynote speaker Nikolas Badminton joins us on Canada Now. And Nick, for our first conversation of 2021, let's talk super fast quantum internet and the progress that has been made in achieving that.
Yeah, over the last few years, quantum computing is one of these sort of edge computing sort of applications that's been coming to the fore. This is the use of quantum phenomena such as superposition and entanglement that help processing of massive amounts of data faster than ever before. So when you can do quantum computations, you can really get through things like encryption, and you can start doing calculations, mixing it with AI, and doing a number of different things to make the world more powerful from a computing power perspective. But what's really interesting, and when you reached out to me, it was like, yeah, let's get into this, because quantum teleportation was just achieved over a 44-kilometer distance.
And that's a big thing, because it's the accuracy, but it's also the distance as well. Like those, it's like that's two big achievements in one shot, right?
Yeah, absolutely. So with data, if you can do if you can use the idea of entanglement and superposition, and you can work out where photons of data are going to be subsequently at the same time between hugely vast distances, then we're breaking the idea of the need to download anything. And it's like, okay, I've got this data here. It's instantaneously with you halfway around the world, and this sort of solves a lot of problems in terms of secure data transmittance and security, and when we start going into space, really fast transmissions of data, things like the Artemis project on the moon in the next couple of years is going to use this kind of technology to really help those communications work well. So this is really interesting, and this is still really edge and really niche and really in the laboratory, but this is where personal computers, mobile phones, and all this technology started. So I think it's really interesting.
Okay, so we're still years away from like a city-sized quantum network being constructed.
Yeah, absolutely. Because what's really interesting is that this technology isn't easy to run. These are very sensitive computers that need to be in isolated rooms, isolated from the Earth's magnetic field. They need to be run at near absolute zero. And so we're not just going to run these in government server rooms or whatever. So these are going to be in university institutions. They're going to be in big tech companies. They're going to be in these research labs. But they're going to be able to solve some really big, important problems. And things like the ability to break encryption are really worrying for a lot of people, like banking and people in cryptocurrency and whatever. So people are starting to work on whole new applications within the quantum computing field, so we can really make the world more secure and a little better place to be when you're processing data, ensuring privacy, security, and data transmittance.
So it sounds like hackers would be out of luck with a quantum internet, but I mean, I'm sure as we speak, hackers are working on it, going, all right, how can we stay ahead of the game? Because it feels like they are always one step ahead.
I mean, you can't go to the internet and buy the things that you need to make a quantum computer, and certainly not easily. So, we're not really going to see this as being the focus for hackers and people trying to get over and above on this. This is one step ahead of the hackers, and we don't often get to say that. But at the same time, this isn't widely distributed. It's not widely applied. So, hackers are still going to be here causing mayhem. But, if we invest in this, and there's been a huge amount of investment around the world, then this is going to really help us in a number of different fields that can really revolutionize how we understand who we are and what we're doing. Everything from drug development, financial modeling, weather forecasting, electronic materials discovery. All these things can be revolutionized in the laboratory using quantum computing, and that's incredibly exciting for many people.
Well, will a quantum internet replace what we have, or would it be kind of like a special extension of it?
You know what? It's going to be special applications of this. So in applications that you need super fast transmission of data, super secure transmission of data in very particular circumstances that are highly mission critical, that are very, very valuable, you will find the investment in those areas. But for me and you to suddenly connect over Zoom or whatever technologies using quantum internet is not exactly going to be the way it works. Certainly for the next 10 to 20 years. I mean, but, looking out 30, 50, 100 years, sure. Once we can get, quantum supremacy and some of these ideas of processing and cheapness of materials and hardware and infrastructure, then absolutely, why not? But it's a long view to that point, Jeff.
Well, Chinese scientists claim to have built a quantum computer that is able to perform certain computations nearly 100 trillion times faster than the world's most advanced supercomputer. Will China be the first to this party, Nick? Like, is Google keeping up?
You know what? There's a lot of high-tech players. Basically, people like IBM and Google and Microsoft and all these other places, like even smaller companies like Station Q that was spun off from Microsoft, and even lots of startups are really putting time and money. There's lots of very smart quantum physicists and quantum computing people out in the world, many in Canada as well. And everyone's working towards this idea of becoming supreme through quantum. So quantum supremacy, the idea that you can take a problem that's performed by a traditional computer. It might be something that's performed by a supercomputer. It takes, 3 months to perform, and a quantum computer can do it in microseconds. So that's what these Chinese scientists are claiming to have done, is that they've taken a problem and they can solve it infinitely. I mean, even the word exponentially doesn't really sort of describe what this is. It's the ability to just really remove the idea of sequential processing of data into a quantum state where almost instantaneously, using this entanglement, using superposition and other quantum effects, you can immediately solve a problem. Now, this is kind of like a solution looking for problems to solve. But you know what? We're going to unearth these problems, and I think that this is incredibly important for really breaking the code, I think, at a cellular and quantum level of so many applications out in the world, especially from an environmental and humanity perspective.
Well, where is Canada in all of this? Because usually when we talk about tech and the advancement of tech, China is usually the first country that we're talking about. What about Canada, and what are their motives here, if any, to be on top of quantum teleportation?
About 3 or 4 years ago, I was out at the University of Waterloo, and I went to the Institute of Quantum Computing. I've got a friend there, Michele Mosca, and he was taking me through what they're doing. So we're quite advanced here in Canada. There's a lot of startups. One of the world's first commercial quantum computers was by a company out of Vancouver called D-Wave. There's a lot of controversy in the quantum computing world, whether it's a true quantum computer, whatever. But, they took the step forward and they were the first there. And you can have some on-demand time processing using their quantum computers. I mean, they actually sold hardware to NASA, to Google, people like that. Canada was the first. And now what we've got a group of companies that have come together to form Quantum Industry Canada. And they're really trying to work out, how does quantum computing work, quantum sensing, quantum communications, very much like we've been talking about, quantum safe cryptography. It's about a meeting of minds to try and get people working in the same direction. I think globally that's happening as well. But obviously, when you're looking at the US and the UK and people like China, everyone's got closed doors and they're trying to do it on their own because, there's value in sort of breaking some of these boundaries around encryption and a number of other areas as well. So Canada is there. The brain share is there. I mean, University of Waterloo is one of the world's leading places in this. So, I think it's an exciting time to be in Canada, especially if you want to look for a career in quantum computing.
Well, is government behind it? Like we've got the talent here. We've got some of the institutions, the startups as well. There's one startup I want to ask you about out of Toronto. in a moment. But is government behind this? So when a University of Waterloo, say, would go hat in hand and ask for some kind of a grant, I'm not going to say easily obtained, but is there a conversation there?
There's definitely a conversation. The National Research Council of Canada, otherwise known as the NRC, has identified quantum tech as a $142 billion opportunity. I mean, we could employ over 229,000 Canadians by 2040 in this field. So it could be really, really good for the economy, really good for, you know, what we're trying to do as a country that's steeped in this idea of research and development and innovation over hundreds of years, right? Is the government stepping up? Well, you know, they're showing an interest. Are they suddenly writing very large checks? I haven't seen lots of that happening. Down in the States, there was $1 billion is being invested into a number of areas, including artificial intelligence, quantum computing, whatever. And I think that up here in Canada, I would love to see the government step up. Obviously, it's tough when there's other priorities. But really, you know, this is a priority for the next 5, 10, 20 years. And if we're not ahead of the game in quantum computing, we could be in dire trouble, especially when encryption starts being broken all over the world by other countries and other agencies.
Well, what do you know about the Toronto-based biotech startup Protein Cure? Like, are they about drug development and medical purposes?
I don't actually know too much about that particular company, to be honest.
Yeah.
But when you actually look at the investigation around protein and drugs and human biology and starting to look into the quantum levels, there's a huge opportunity to really revolutionize that field. I think you're going to see companies, you know, large and small, very much like the company you spoke about, Big Pharma as well, start to really look at this technology and take it very seriously. And you know, I think that being a quantum computing scientist is going to be the new sexy occupation that the high-tech companies and Big Pharma and whatever are going to go after, just like artificial intelligence was in the last couple of years. So we're going to make sure that we don't have a brain drain from Canada. And suddenly, you know, I can't say people are going to Silicon Valley anymore because there's hundreds of thousands of people leaving there right now. But they're going to leave and they're going to go to countries and companies that have got really good funding. So government needs to step up. Startups need to be part of the ecosystem. Everyone needs to bandy together, and everyone needs to get behind quantum computing because, you know, it's going to be the future, Jeff.
Well, what is going to be the biggest benefit? Like, you talk about cybersecurity, you've talked about like drug development, AI. How do you see quantum computing benefiting us the most?
I think first and foremost, I think security, the security communication, security of systems is going to be the absolute number one benefit. I mean, there's a lot of discussion and people throw away comments and just say, oh, it'll break encryption immediately. Bitcoin's going to be mute. Banking systems are going to be broken. The world's going to be forced into turmoil. I don't look at the world in those terms, right? But encryption is going to be incredibly important. I think drug development is going to be incredibly important, and really unlocking more secrets at the quantum level. I think that quantum physics, this entire area, I've been following it for a good 3 decades at this point, and I'm by no means any particular expert in quantum theory, but I'm sort of a fanboy, and I just think that this is something that people are going to look to for lots of opportunities. But again, it's an area where once you start unlocking these secrets of the universe, you're going to find a lot more problems can be solved. You're going to see a lot more problems can be uncovered. And do you know what? The more knowledge we have, the better the world is going to be.
Check out NikolasBadminton.com, futurist researcher, keynote speaker Nikolas Badminton. That's why we have you on once a week, is so we can obtain some of that knowledge so we can be that much better. We appreciate it, Nick. Thank you so much.